So I'm going to talk about component files. That is what's going to be new in 14, or is new in 14, and what is likely to come in the future, and the DFS. And the majority of it is indeed about the DFS. So what I hope to cover are new features in 14, DFS, and then future possibilities. So 14.0 cannot create new small span files. Small span files are so cool because you can't create them larger than 4 gigabytes, you can't put large components in them, but there's a whole bunch of other things you can't do with them either. They didn't keep up with changes to the interpreter, so there's problems with interoperability and so on, and they really are obsolete technology almost, so using them is a really bad thing. So as of 14.0 you can no longer create any new ones of those. People who saw me this time last year will be surprised that that's all I'm telling you, because last year we said that you wouldn't be able to write to any existing ones either. We were told by a number of people that this would give them some immediate problems, so we've deferred any change along those lines. It's still our intention that small span files should eventually disappear, but the schedule has been pushed back somewhat, and when we resume that schedule we'll announce, as we did at the beginning of 13.0, that it was our intention in 14 to remove support for writing to them. We will make that announcement again, but at the moment we're not making it. So another new feature in 14 was variant options. You can now create a file and specify various properties about that file, such as its journaling level, its checksumming level, and its compression level, about which I'll tell you about a bit more in a moment, at the time you create it, and then not have to do a separate quadfprop stage afterwards. That's a convenience, as well as the fact that it's pretty stupid to create a file in one form and then immediately transcribe it into another form. So when you use the option, there's no conversion phase. Now, I said you can do those 3 properties, J, C, and Z. There's also S, which is the size, a 32 or 64-bit word size in the file, large span and small span, and the Unicode property, which are not supported. And we were asked to do that in 14.1, so we probably will. It's pretty useless because S can only ever be 64, and Unicode ideally is always going to be 1. We've also put variant on to quadfchk. So quadfchk, when it was first implemented, has a left argument which says what to do in the event of finding file damage. You can now use variant instead if you'd rather. As an alternative, both are supported simultaneously. The main part of version 14 is performance. So we've done 3 different things to increase the performance of component files in 14. Okay, so we've rewritten the code that reads and writes to a file in a way that it's much quicker now. It uses more memory, which is something we now got to use, I guess. We didn't when it was first implemented. And it just gets your code faster without you having to worry about anything. You should notice that if you've got a fast network, if you've got a congested network, if you've got an array with many elements of mixed type, that things get quicker without you having to do anything. I'm getting some feedback from people that are using 14 that that is indeed the case. And it's certainly matched in our performance tests. We've also introduced some new syntax that allows you to read multiple components at once, such as that. So the old syntax, hang on, there, will read many components, in this case 10 components from the file, give you a 10-element vector where each element is the individual components. The syntax on the left will give you exactly the same result. That's quite a nice syntax, but the real point of that is that if you have a shared-side file, this is 10 separate quadf reads, and there are 10 separate locks and unlocks of the file, and that's the expensive part of a file operation. In this case, there is only a single lock and unlock, so it runs much more quickly, which is what the next slide says. There's also a semantic difference, because when the file is only locked once, in this case, no other user can come along and amend the file in the meantime, so that becomes atomic, whereas that is not atomic unless you put quadf hold around it and you all obey the rules. So there you go. This is also faster, but you do now have to change your code to take advantage of it. So if you can identify cases like that, even if they are multiple f reads, one after another, changing it to that is good for your application. And as I said just now, it's all about the locking. So if you've got an exclusive tied file, this does you no good at all in terms of performance, because there is no extra lock when you do an fread. It's only locked at the tie and the untie. And the third performance thing we've done is compression of components. You create a file now. If you set the Z property when you after you created it, or now when you create it, this means that every subsequent component write will be compressed. That is a process which takes time to do that compression, but it makes the data which is transferred to and from the disk much smaller. So if you've got a relatively fast processor and slow network, then it will give you good advantages. There are cases where it can actually slow things down, but you still get the advantage of smaller files. Again, people have said they've been getting some good speed-ups because of this. If you've got a compressed component on your file, regardless of the Z property, it will automatically be decompressed, so it's completely transparent. But only version 14 can do that. Earlier versions will give a domain error if they try and read that component. As I say, you get your gains there on relatively slow networks because it's the data traffic which slows down. And that's all I have to say about version 14 of component files. The bulk of this, as I said, is about the DFS. I wanted to give a pretty high-level view of what the DFS is before I start. Yes?
You say that the reads, you've got that, you can read a vector.
You can read into a vector, read multiple components into a vector. Yeah.
Can you also write to multiple components?
No.
And can you do an append in the same way with the one file lock?
No. In fact, the third stage of this presentation is things for the future, and extending that to the write operations is something that we have in plan for some stage in the future. The biggest hit was in doing it on reads, because you tend to read far more often than you write. So we did that first.
Speak for yourself. Okay, thanks.
Yeah, it is coming. It's coming, it's not there yet. Okay, so this is not a DFS scenario. We've got some kind of file server sat in the middle of the picture here. And it's completely dumb. It's doing nothing but exposing its file system to the rest of the network. And we've got a whole bunch of clients which are accessing those files by mounting the file systems. The important thing is that these clients are individually reading and accessing the file. Any updates that are made to the file are made by the client over the network. And they're all jostling to get access to these files. So there are file locks being used. Each of these clients is trying to obtain a lock on the files on this server whenever it needs to make an update or a read to the file. When you have the DFS in the picture, you now put some intelligence on the file server. So it sits around the files. It is accessing the files directly and locally, and the clients are now negotiating with the DFS in order to access the files. Instead of exporting this file system, you've got a TCP/IP connection between the clients and the DFS. So I'll give you a bit more of an overview, and then I shall try and explain why that's a good thing. So this DFS that we have, you can use it to support component and native files. It's a client-server application, as that picture obviously showed you. You can, if you want, set it up entirely locally. There are still some benefits of doing that, but most of them are in a client-server scenario, so you've got remote clients accessing the files. There is, at the moment, a limited support for distribution. You can spread the server amongst multiple processes on the same machine, physical machine. You can't currently distribute it amongst multiple machines. That's a future plan. So the DFS is an APL application. Underneath everything that you see are regular component files being manipulated in a completely ordinary way, more or less, by the DFS. It uses APL, it uses Conga to talk to the clients. It's got a My server on there so that you have a web interface so that you can access the server itself remotely. There's a little bit of interpreter extensions being put in to support some of its functionality, but most of it is straight APL. So when you connect to the DFS, you get a namespace, And inside that namespace, there's a whole bunch of functions which are equivalent to the regular quadf functions. You don't use the regular quadf functions with the DFS. So this is a bit more detailed view of the server. On the yellow, we've got the old clients. There's an additional one here. There's a web browser which is just monitoring what's going on. So if I go through these in fairly quick succession, the top process that's running the top service is the monitor function. This is keeping track of everything that's going on and providing the interface back to the web browser so that it can see what's happening. I'll show you a little bit more about what you can do with that in a minute. There's another service which is handling all the file locks. These are not file locks, they are memory locks, and so that works slightly differently, it's a bit quicker. There's a server which is managing all the login requests, and then there are one or more of these file servers. Each file server manages a set number of files which you allocate to it, which is entirely configurable. And then each file server can have any number of delegates associated with it, which can assist when long-running operations take place. So if this file server was managing a bunch of files and someone did something like a quadf copy, which would tie that server up for a bit, all those other files would ordinarily become inaccessible whilst it was busy. So it punts that off to a delegate so that it remains responsive. And then finally, you've got a backup server which can back up your system. 2 or 3 years ago, Morten came up to me and told me about this fantastic plan he had for this, and I humoured him and said, "That sounds great, Morten," but I couldn't really see the advantages, and there are loads of advantages, so he was right. I will try and take you through some of them. Well, there they all are. I won't read the list because I'm now going to take each one in turn and explain them in detail. So the first is security. In the scenario I showed you without the DFS, the file system has been exposed around the network, and any client which can access that server can do anything it likes with those files. It doesn't necessarily even have to use an APL application to get at them. It could load them into an editor, it could corrupt them in any way it felt, it could view the details. It's not entirely impossible to make sense of what's in a component file from a binary dump. With the DFS, that access is now taken away. You've got to go through the DFS through your APL application. You have to log on, you have to authenticate yourself, and in particular you can't just spoof yourself as being user ID 0, which you can on Windows very easily, and get full access to the file regardless of what the access matrix says. If you've got an access matrix, it will be honoured. And then there's performance. This is perhaps the most surprising advantage of the DFS. You think with an extra APL layer between you and the files, things could only slow down, but in fact the complete opposite is true. And the reason is the DFS is managing your files, and it only ties each file once. It takes an exclusive tie. And exclusive ties are much faster than shared ties because there's a lock at the tie and a lock on the untie and no locks in between. And locks over networks are the things that are slow. Not only is there the locking benefit, but the interpreter knows that if it hasn't unlocked the file, that its caches are still good, so it can retain caches between operations. When you had multiple clients, each accessing the file, each with their own set of caches, the interpreter has no idea that its caches of the file contents are valid each time it unlocks the file, because someone else may have updated it. And for the same reason, fhold in particular is faster. The algorithm for fhold, which involves multiple files at once, does not scale at all. So if you try and hold one or more files and another user is also jostling to get those files, as you add more and more users to that mix, fhold gets progressively slower, whereas with the DFS, it's much more linear. The delegates I told you about just now, to keep the server responsive, don't provide an advantage of the DFS over component files, but they ensure that the advantage of the DFS is maintained. And so it's always been the objective that you would get better performance with the DFS compared to regular component files if you are in a Windows client-server situation. And indeed, that is the case with typical data that we use. Right, so next advantage is what I've called resilient. In the DFS scenario, you have a single server which is accessing the files. In a regular client-server application, you've got many clients, each accessing the files individually and doing their own updates. If any one of those clients was to lose its connection during an update, the file update would perhaps be left incomplete, which would cause a problem with your file. With the DFS, which is supposedly up all the time, that doesn't cause a problem. Even if a client disappears, the update finishes on the server. Now, of course, oh, and I should say that even if a client does disappear, because the server's still up, you can just reconnect and carry on without, as if you'd never gone away. I think there's one exception to that if you had a quad F hold on the file at the time. So the problems I described with the client-server scenario are the problems that we implemented journaling to solve. So journaling can cure those problems, but we think prevention is better than cure. The DFS should prevent them from happening in the first place. And of course, the DFS does still use journaling files as a last resort. If it goes down, the files are still protected by journaling that way. Okay, the DFS was originally implemented as a mainframe offloading project, and therefore it needed to support some additional mainframe functionality. So there are some additional commands for that compatibility. I'm not going to go into too much detail. fhist, fstatus, fuserknow, and fwhois are all there for that purpose. There's some other perhaps surprising ones. You can rename share tied files. That's a weird thing to do. It causes all sorts of funny things to happen. You've got the concept of usernames. At the moment, every user has a numeric ID. You can optionally enable that in the DFS, and then your access matrix will display names rather than numbers for users and so on. The thing that is missing from that compatibility is a library number, which is an alternative for directories. We don't support that. And there's some additional commands that deal with multiple operations at once. Again, ask later if you want to know what they all are. And there are additional native file functions, and these exist because there is no access to the file system except through the DFS. With the existing situation, if you need to create a directory, you can do that on the network directly. You can't with the DFS, so we've got some additional native file functions. I should say that in some scenarios you would think that having native files is exactly the opposite of what you want. We're talking about all the security, and then we give you native file access to the system and you can do what you want again. So whether you have native file support is configurable. You can switch it all off. Okay. Right, so there is this monitor. I will give you a brief demo of what it looks like in a moment. Just a screenshot. Obviously, the server's running remotely from you. You want to be able to configure it. You want to be able to do various things. So you have this monitor. You can start and stop the whole system. You can monitor usage and performance of the system. You can look at file usage. You can monitor users. You can look at individual operations. You know, how many quad F reads are happening, and you can then drill down, once you've got a big picture, into individual detail as what you want to know about how the system is running. You can edit the overall configuration, things like the number of delegates which are associated with a particular file server, for example. And you can manage clients. There's two things you can do. You can add new users, you can set their permissions and so on. And if you have a situation where a client is connected to a file, it's exclusively tied it or it's held it, and then they've gone home for the day, if necessary, you can come into this monitoring tool and you can kill their connection so at least everybody else can carry on. So I've just got a couple of screenshots to show you what it is. I mean, it's running in your browser. It's a MyServer application. In this particular screen, of which there are many, we've got a list of users that are connected to the system. And it's just, as you can see, a simple list of them, not particularly much detail at this stage. We've got the number of ties they've got, the number of files they've held, and so on and so forth. There's your button to kill them off if they've gone home. But then you can drill down. So the next screen, we've expanded that slightly. We can now see they've got one tie here, and there it's the file that it is, that it's exclusive tie. This user we've also drilled down on, and we can see their files and so on and so forth. Right, so the DFS backup system. The system is able to perform backups as the system is up and running without having to take the system down. It will give you a coherent and consistent backup of the system as it was at the point the backup was started, despite the fact that updates continue. The way that is implemented essentially means that you've got two states, beginning and end of the beginning and current. So there's a slight performance hit whilst that's going on, and the files tend to get a bit bigger, but it does enable you to carry on working rather than take the system down. You can do fuller incremental backups. You can schedule them to happen automatically, or you can go into the monitor and you can kick one off immediately. And if you wish, you can ask the system to compress the backup, and when it's finished, it will tell you that it's done. File locks, which I described earlier on, apply on a per process basis. The APL is running in a single process, no matter how many threads it's got. So whilst you can use Quad F hold to control access to your files between multiple users, if they are separate users on separate APL sessions, you can't do that if they're on separate threads. And then you also have to manage the threads with colon hold as well. With the DFS, you no longer need to do that. It's fully independent of threads, and holds will just work on separate threads. And in fact, you can go further than that. You can have multiple connections to the DFS within a single application. So you could have loads of different threads going off, each with their own connection to the DFS, each with different login credentials if you wanted, each with their own independent set of tie numbers. So I think that's the list of advantages that I had. So if you started using it, what changes would you have to make? So this is the compatibility of the two systems. You've obviously got to log in. You need to identify yourself. As I think I said earlier on, when you get a connection to the DFS, you get a namespace which contains within it various functions equivalent to the Quad F functions that you're used to. So here I've named my namespace Q, and you can see that it's not entirely different to have QF tie instead of Quad F tie, but there is that conversion, an automatic conversion that you might need to make to existing applications. And I've shown you just now a whole bunch of extensions that we've provided. So if you migrate towards the DFS, you should have no issues with the fact they exist. But if you were to go back again and you started using those extensions, they wouldn't be available to you anymore, obviously. But what is really important is that there's no file conversion. Underneath the covers, it's regular component files. So you can bring them into your system, take them out of your system exactly as they are. Okay, so the DFS, we've talked about it for quite a while. There has been version 1 for about 2 years. It is a single site. Version 2 release is imminent. Version 2 is, I believe, ready and complete, with one exception, and that is that there's not much in the way of documentation yet, as I think Fiona said the other day. So when that documentation is done, imminently, DFS will be made available. If anybody wants it sooner than that, with the documentation that does exist, they can ask for it. It's a separately licensed product. You don't get it with the interpreter as you do with some other tools. It's a significant development work, and there will be additional support requirements, and therefore there's an additional cost. Feature possibilities. This I might do a demo, I might not, because I've timed this and it's very close. So things that we might extend to the regular quad file functions would have to be echoed in the DFS as well. So what I say now would apply to both. And this answers the earlier question. We would extend the multi-component tie. The multi-component read that we've got, we would extend to write and append an FRDCI to give the similar advantage when you are writing a file and reading in this case. And then another idea we're looking at is asynchronous reads and writes. At the moment, if you do a file operation on a thread, then that's not a thread switching point. All the other threads continue running, and they don't necessarily need to. So they could be allowed to continue running. That would have some that would have to be configurable because some people depend on that behavior, but it should give another performance gain. Yeah, Björn didn't entirely put me off the other evening, but I did realise that encryption was much harder than I thought. That is something that we would like to look at, and it would work in a similar way to compression. You know, it would happen semi-automatically. Oh, I have a question. Someone want to give a microphone to Ziggy?
Yeah, I'm just confused. F write, is that the same as F replace or replacement for F replace?
That's me writing slides far too late at night. One of them should be F append and one of them should be F replace.
Okay. No, it makes sense.
On Tuesday, this presentation took an hour and a half, so I've hacked it very late. You should never do that, but I was just too far behind.
I'm not going to sling stones. I have to do a presentation in a couple of hours.
Yeah. No, you're absolutely right. That is me being utterly stupid. That is a replace. Well spotted, thank you. Okay. Where was I? And transactions. We mention these from time to time. I like the idea of them a lot. What you would do is identify a section of code as a atomic unit. You may currently have quad F hold around that unit at the moment, but what a transaction would do would be to guarantee that the whole sequence completed or did not, and if anything failed in the meantime, the whole sequence would be rolled back. And it would be, unlike a quad F hold, it would be mandatory, so there would be no need to have the other applications using quad F hold. You'd be making single commands basically out of functions out of many. So there's quite a lot that I'm thinking about doing to the code, and it's quite old code. There was a real nasty problem as far as I'm concerned. We put out the very first release of 13.2 had a problem with locking, which could cause file corruption, for which I've been holding my head in shame for quite a long time. So I've been experimentally, on Friday afternoons, looking at how I might take the component file code out of the interpreter into a separate library and simplify it. So, as I say, I've very carefully written experiment, because at the moment what I've done is nothing more than an experiment, but it would be a separate library which you could take and link to the interpreter, initially perhaps in addition to the interpreter, so that you can use alternately whichever one you wanted to. But we could link it to other tools so that we could have a completely freestanding quad F chook, which you could run from your Unix scripts or whatever. What the demo was going to show is that there are some, in addition to the things that I say I want to add, there are some annoyances with the current code that are very deep grains, some of them not just in the component file code but in the interpreter. One of them is that there is a limit of 254 at most component files which can be tied at the same time, and that reduces if you've got some other things going on as well. I've written a library which so far can do nothing more than read any component file, but it doesn't have that limit. It doesn't have any system limits of its own. Obviously you've got system limits, so there is a maximum file number of things that you can tie, but it won't be that limit won't be imposed by the new code. There's another current annoyance in that if you tie a file or you try and access a file which has got a journal in it, the first thing that the interpreter tries to do is to write out that journal back to the file so that it can carry on processing it, which is fine so long as you've got write access on the file. And if you have a setup for security where you make your files read-only because the user's only reading them, you may find that you try and tie a file or read it and it says it hasn't got permission to write to it, and that's because there's a journal there. So the new code can deal with that. It will deal with the fact there's a journal in there and it will carry on working. So demonstration is not going to happen. It can read at the moment. It's a long-term experiment. It may or may not happen. And why it may not happen, it's huge. Morten may eventually decide that I'm spending too much time on it and tell me to stop. It may not perform well enough. At the moment it is between 0 and 5% slower than the existing code because it's doing a lot more internal validation. This problem that I said at the release of 13.2 is hopefully never going to be seen with this because it checks every single time that it accesses its caches that they are consistent and coherent and it's allowed to do it, for example. We may find that if, particularly on errors, it gives a slightly different error to what the old code did, and that may cause sufficient problems that people don't ever want to use it. And of course, the existing code is old, but it's tried and tested, and people may not just trust any new code. So I have written lots of additional QA. I mean, there are now thousands of component files, slightly different, all created by existing interpreters in a big repository, and I've checked that this new code can read them all successfully and correctly. But there's always that risk. So what I told you is just me dinking around. I'm having great fun doing it, and hopefully it will happen. Okay, so for the DFS, future possibilities, stored procedures. So exactly as you said, push some of the processing onto the server, make certain updates. APL code will automatically get fired off on the server and continue to update the file or do whatever you want.
This is essentially the ability to run your own code on the server side, same as stored procedures in a relational database, right?
Yeah. Component caching. So the interpreter already caches the various parts of the component file, particularly the indexes and the root, which is the global file information. Individual components don't get cached apart from whatever the operating system does. It would be great to add that to the DFS so that certain reads and pens would not necessarily go to the disk at all. Get some better performance. Encryption and compressions come up again. We're talking here about the communication link between the client and the server. Ziggy.
Yeah, I was just going to ask, in terms of the caching or component caching,
Yep.
can they be user-defined? I mean, as the programmer, can I say, actually, I want this section to be cached?
Well, this doesn't exist, so obviously that's something that could be done. But it's just things that are on the list for doing that hasn't been designed and planned yet, so there's no answer to that question at the moment. I would feed that back in to us as something that you want.
Yeah, it just makes sense to me. If the system's deciding what to cache,
Yeah.
it won't always get it right. But if I know what I need to be the fastest component,
absolutely. I agree with what you're saying. I'm not behind that decision at this stage, so I don't know what's being thought. I can tell you that the caching that takes place in the existing component file code upon which the DFS is based is not in any way user configurable.
Right, okay.
But it tries to do its best. Another useful thing would be to have multiple DFS installations simultaneously. So your application wouldn't change; it would just update and read the files as before. But every write would be sent off to multiple DFS servers, so you've got automatic mirroring taking place. And I said at the beginning that the server is only slightly distributed at the moment. For scalability and load balancing, it would be good to be able to spread the services amongst multiple physical machines. And so that's something that's on the plan for the future, I believe. Okay, finished ahead of schedule. So I briefly summarised what I said. I talked about 14.0, mostly performance improvements. This used to say, please don't use small span files, and it still does, really. The DFS is imminent, and to remind you again, if you want it sooner, come and talk to us. And we've got some ideas for the future. Thank you. Is there any more questions?
Richard, you didn't explicitly mention this, but presumably this the system runs in various environments, like Unix environments as well as Windows, correct?
We're talking DFS here.
Yeah.
The initial thrust is towards Windows, because we think that the typical Windows client-server scenario will benefit from it the most. If you've already got a system where our current Unix user base is, where they've got their own servers managing files locally, then it's not such an immediate benefit. I believe that longer term, though, it's going to be extended to other platforms. Is that right, Morten?
Yes, I think once we get into the distributed features and the mirroring and so on, this may be a technology that becomes interesting to the large Unix users. But at the moment, they're sort of already there because they're running the client application. It's already a client-server system that you're running. So getting that performance speed up in that scenario is very, very difficult. On the LAN, it's like falling off a log, getting the better performance. Yeah.
I should have said when I talked about the authentication that happens at the moment, we're supporting a simple login process and IWA, that's integrated Windows authentication. Obviously, that will be extended to others, but those are the two at the moment, I believe.
How do you handle the potential for corruption? In other words, the ability to roll back rights that are done in the event that you know that corruption has occurred?
That's an interesting question. There is no rollback facility in the current file system, component file system, except for, it's sort of there without the rollback. There's the roll forward, but not the roll back, if you see what I mean, for the backup system. And that's what would form the basis if we did it of transactions. So transactions will be the way to go for rollback, but it's something for the future. It's not currently there.
But in terms of corruption, there is rollback, right? At the moment, when you do an update to the component file system, it's written to a journal. And if that journal is
yes.
not complete, it's automatically
Yes.
rolled back. And if it is intact, then it's rolled forward. But
Yes.
it's not explicit rollback forward, it's automated.
Yes, if you lose a connection to the file, or your server goes down, or your client goes down, as Morten says, it creates a journal first, it then does the update, and then it takes the journal away. So if there's a journal there when the next user comes along, it finishes the update. So there's no corruption in that manner. That's if you enable journaling. Any more? Sounds like we're done. Thank you.